Welcome to Train Signal. I'm Chris Bryant, CCIE number 12933, and this is video 17, Route Maps and Policy Routing. And if you've just finished watching the BGP videos and you're looking at this whiteboard, you're thinking, oh gosh, thank gosh, a short lecture. And I want to tell you, though, that while this is not going to be the longest video in this course, the information in this video is misunderstood by more CCNP candidates than any other part of the course. And I don't mean after you take my course, I mean before you take it. You're going to see some terms in here that don't quite mean what you would think they mean when you look at them. We're going to see some of those on the routers. We're also going to take a look at how route map operation differs from some earlier technologies you've learned about, namely access control lists and prefix lists. And these are vital differences. They seem kind of minor, but they're going to cost you in a production network, but if you don't know them, they're really going to cost you in the exam room. Because as you'll see, route maps are used primarily with BGP, and obviously there's a lot of BGP on the BSCI exam. Not a lot of route mapping, most likely, but you've got to be fluent with these to pass the exam. And like I said, there are some common misconceptions. I'm amazed at how often I see people get these mixed up, but you will not have them mixed up after you watch this video. So we're going to take a look at route maps, then talk about policy routing. That's a phrase that gets thrown around a lot. Well, we're doing policy routing there, but you don't really know what it means. You're going to know what it means when we're done here. We're going to talk about PBR fast switching for just a few minutes. That's not going to be an in-depth discussion. There's not a lot to it, but it's important exam material. And we're going to finish up by taking a look at the differences between the set commands, IP default next hop and IP next hop. And again, at the very tail end of this, we're going to go over one or two other details. So I kid you not, knowing the material in this video and not knowing it can mean a 75-point difference on your exam. And I think you'll agree with me, that's a lot of points. And on top of that, when you're out in production and you're putting route maps in, you've got to know exactly what denies mean. And I don't use capital letters very often on whiteboards, but I do it a couple of times in this course, and I think you'll see why when we're done. So when I'm using caps, I'm not yelling at you, but I am saying, hey, this is really important, and this may not be what you think it is. But right off the bat, route maps are very similar to access lists in their operation. They're going to go from top to bottom, and just as with ACLs, the first match will take effect, and everything after that doesn't matter. And generally, when you write a route map, you're going to write an access list to go with it, to identify the traffic that would be permitted or denied with route maps. But route maps go way beyond send or don't send. They don't stop at that. What they actually do is change data values, and by that I really mean attribute values. They're not going to change the data that's contained in the packet, but they will change a next hop attribute, an origin code. They can change just about anything as far as path attributes go. So that's why you're going to use route maps primarily with BGP. Another difference between a technology you learned earlier in the course, prefix lists, route maps are similar to those because they do have sequence numbers as well. So when you go back to add a statement to the prefix list, it's easy to do, and you can put it exactly where you want to. If you do not specify sequence numbers, they are given default numbers that increment by tens, not fives, tens. And here's the first time I'm using caps for you to yell at you and say, hey, look at this. Major ACL and route map difference. In access control list, deny means don't send this. You have to break from that convention when you're looking at route maps, my friends, because here deny means route it normally. And that may not make much sense to you if this is the first time you've looked at route maps. It will make more sense to you when we're done. But I want to reiterate that if you are denying in a route map, that means that you are routing normally. You're just not doing what the set command says to do or not do. Let's just take a quick look at a basic ACL here and a basic configuration. First thing we do is write an access list that's going to identify traffic that will be permitted or denied. And we'll just we'll use access list 17 again. And we'll do a permit host 2111. So we've identified the traffic 2111. Looking at the syntax of a route map, we've got tag right here, which means we've got to give it a name. And again, please give it an intuitive name. I'm going to call it change next hop because that's what we're going to do. And you can see that iOS Help shows us that the next option, we actually have 4. We could hit enter here to create it and drop down into route map configuration mode. We can do a deny or permit, and notice here that it says next to deny, route map denies set operations. That means that if there's a set command in that clause, it will not be applied to this traffic. There's nothing here that says traffic is dropped. And the number value you see there is the sequence to insert to delete from existing route map entry. So if we already had a route map with 5 statements, they'd be numbered 10, 20, 30, 40, 50, and then you could just, if you needed one to go between the first and second statement, just number it number 11 here, and it would be inserted there. So we'll just do a permit 10 here. Then we drop down into configuration mode, and we're going to write a match statement first. Match address 17, which means that any traffic coming in that matches this ACL will be subject to whatever set command we put in. And you recall from your CCNA studies, I'm sure, that a standard ACL can only name the source IP address. That's the only thing that can be, is the source IP. So any traffic coming in from 20.1.1.1 as a source IP address is going to have something set, and here's everything we can set for a packet. And you can see most of these refer to BGP. You see AS path going from top to bottom, community list, community attribute, output interface, so we can set the interface that it's going to leave. We can change the local preference. We can change the metric, and you remember that's actually the MED, the multi-exit discriminator. We can change its origin code. We can change its weight. We can change just about anything. We can change any attribute, actually. None of them are immune. And that's just how it works. That is a basic route map. And we could just set an IP next hop of 10.1.1.1. So now packets sourced from 20.1.1.1 will literally have their IP next hop address changed to 10.1.1.1. That's going to be the next hop for that packet. So you can see that route maps are very, very powerful. But again, I want to reiterate that with route maps, permit means that the criteria in this route statement will be matched against the traffic, but deny means it won't be. Denies in route maps do not mean the traffic will be stopped. They do not mean that. Again, all route maps run from top to bottom. They stop when a match is made, and route maps also have our old friend the implicit deny. So we have our implicit deny. Let's take a quick look at policy routing here. You hear this term a lot. And policy routing is simply the use of route maps to determine the path that a packet's going to take to get to its final destination. And again, route maps are one of these things you really need to get your hands on in a home lab environment or a rack rental environment, because you've got to practice setting that next IP hop, making sure that works, using the IP default next hop command and seeing when that works, changing attributes. You got to get in there and really do this stuff. And for those of you who go on either to the IE or a Cisco Quality of Service certification, if you're not familiar with the Cisco term QoS, it basically is traffic shaping. It's sending packets where you want them to go, handling packets in an order of preference. It's obviously a lot more to it than that, but basically you have control over how the packets are handled. And what you'll see as you progress through your CCNP studies as well, traffic is marked by policy routing. And what happens is you're giving different levels of service to various classes of traffic. And what actually happens is the traffic is marked and then placed in different queues in the router. And if you're not familiar with QoS, and I find a lot of times people have heard the term and they haven't, here's a router with one outgoing interface. And we're going to look at what actually goes on inside, because what we're going to have are some queues waiting to send traffic to the outside. And we'll just call them H for the high queue, medium, normal, low. And in networks where congestion can be a problem, what you can do with quality of service, one of the many things you can do, just giving you a little QoS preview here, is you as the network administrator can actually configure what kind of traffic should be put in that high priority queue, which traffic should go in the medium queue, which traffic should go in the normal queue, and then which traffic should go in the low queue. So if your router is often congested a bit, you can say, okay, you know, my FTP packets have to go through, or this kind of traffic can be put in the low queue. You have to be careful, though, because what the router will do is if there's traffic in, say, the medium queue and high priority packets come in, it'll stop sending the mediums and go up to the high and send those first, which is what you want it to do. But if you put too much traffic in, say, the low queue, it can end up sitting there for a long time because the low priority traffic will not be transmitted until those first three queues are empty. So just a little QoS preview there for you. It's fascinating stuff once you get into the nuts and bolts of it. Really is. Now for policy routing, there are some basic rules that you should know about. Three very important rules for the exam and production networks. First is that policy routing in no way affects the destination of the traffic. Makes sense. I mean, we don't really want the destination changed, but it will affect the path taken to get there. And again, we do that by path attribute manipulation. Policy routing can forward traffic based on the source or destination IP address or change attributes based on that. But again, you recall from your CCNA studies, and be careful about this in exam questions. You know, watch those ACL numbers, because you've got to remember your ACL numbers. And in this situation, if you want to enforce policy routing based on destination IP address, what have you got to use for that? You got to use an extended ACL. You cannot use a standard, because a standard ACL only applies to source IP addresses. And finally, and what gets confusing, is that you can enforce policy routing at the interface level or at the global level. And when you apply policy globally, this is another major misconception. When you apply it globally, the only packets that are affected by that are packets generated on the local router. Because I've seen people say, oh, well, you know, global, because you, of course, as a CCNP candidate, you know darn well what global means. And you say, oh, well, global configuration, I'll just configure policy routing globally, and it will affect traffic coming into all the interfaces. No, it will not. It will only affect traffic locally generated. Let's take a look at that local configuration first, though, here at the top. And I did these on the whiteboard so you could compare the two commands, because they are not the same. Again, applying policy routing on an interface only affects packets arriving on that interface. Notice that here there is no in or out option. And the command to put that on the interface is IP policy route map, and then just followed by the change of the route map. I remind you here again of a couple of things. First off, applying that policy globally only applies the route maps to packets that are generated locally on that router that you're writing the config on. It does not affect all packets received on all interfaces. I say that twice because that's what I used to think before I started really studying it. The first time I heard that, I thought, well, you know, globally it's going to affect all of them. A lot of people think that, but now you know better. And here's the command to do it, and I wrote it in global config mode there. It is IP local policy route map. So the command actually helps you remember what's going on with it. It is a local policy, but it is applied globally. And one more time, if a packet does not match any of the specific criteria in a route map, or matches an explicit deny, the data is not denied transmission. It is sent to the routing process and will be processed normally. I promise not to say that for another 2 minutes at least. But I think you'll agree with me that's kind of counterintuitive, because so far in all your studies, you earned your CCNA and you're working on this BSCI exam, and everything you've learned up to this point is that when you've got an ACL and deny, that means the traffic's being denied. And that's true, but now we have to change our thinking a little bit when it comes to route maps. Now here's what you can do though. Let's say you have a situation where you do want some packets to be dropped that don't meet any specified criteria. You could, at the end of your route map, put a set interface null zero statement, and that's it. Let's take a look at the pod here. And what we could do here, we're going to add just one more concept, one more line here to our existing route map. And the first one, again, we said if it matched IP address 17, then it would be set with an IP next hop. It would be sent to 10.1.1.1. But let's say, just in an extreme example here, that if it doesn't have a source address of 20.1.1.1, we want it to be dropped. What we would do is add another line to our route map, and we'll go ahead and name that 20. And notice that I'm putting permit here. Permit means that any traffic that matches anything I put in here will have the set statement applied to it. But I'm not going to put a match IP address command in. And what that means is all traffic is going to match it. I don't have to have an ACL in here. So I'm just going to put a set statement, and I'm going to set the interface, and notice that one of my choices is indeed the null interface. Cool stuff if you know where to look, because now all traffic that doesn't match the first clause of the route map will match the second. And it will be everything else goes to the null interface. And that set command, of course, when you're setting it to null zero, that should be the final set command. That's kind of your catch-all. Anything that didn't match anything earlier in the route map, we're going to send it to null zero. But make sure you put permit there, not deny. And on exam day, that's a good detail to look out for. I wouldn't be surprised if Cisco tried to just make sure that you knew that. So let's take a look at a longer example. And it's a route map and an access list that I wrote before we began this video. And I put a few extra spaces in here just so you could really see what was going on. I've written a 4-line ACL here. Well, actually 4 separate access lists. And they're each permitting one different IP address. Then we've got a route map below that called example permit 10. And it's got a match IP address 29 statement with a set IP next hop command underneath of it. Then I've got a deny statement under that with a match IP address 30, and you'll notice that I don't have anything there for 30 or 31. Because there are actually 4 possibilities for an incoming packet when route maps are in use. And this example that we're going to look at illustrates all of them. And what we're looking at here, I've made a little chart, and we're going to see what would happen to an incoming packet that was run against the particular route map that I just wrote. And we're assuming that the route map has been applied to Ethernet 0. So let's take a look at that again. If a packet comes in from 20.1.1.1, it matches line 29. But if we look at the route map, it goes example permit 10, and remember the route maps are going to run from top to bottom. And the first match statement is match IP address 29. Well, yes, a packet from 20.1.1.1 will match ACL 29. So we're in business there. So it will then have its IP next hop address set to 40.1.1.1. So we can see right away that's pretty elementary, because it matched clause 10 and it's going to have its IP next hop set to 4111. So let's go down the list here again to 2222. If a packet is sourced from 2222, then it matches the deny statement. And what actually happens there is that there is no action set there. It's a little tricky. Yeah, it matches this, but there is no set statement. So since there's nothing there, this packet would return to the routing engine to undergo its normal routing procedure. So let's put that up on our little chart here. 2222. It's got a deny with it. So one way or the other, it would be returned to the routing engine and routed normally. So now we go down to 2333 and 2444. And there's nothing to match. The route map does not match them. So there's no action taken by the route map, and again, those would be routed normally. But let's say that we wanted to specifically block traffic coming from 2333 and 2444. What we can do in that example is use multiple match statements in one route map clause and have the packets matching those two addresses sent to the bit bucket, interface null 0. And the reason I wanted to show you that, we can go back, let's do a show route map here, and we see example and change next hop. So we can see the sequence numbers, for example, were 10 and 20 the way we set them. This is a great command because you can see the match clause, you can see the set clause, you can actually see how many packets have matched it. And this is a great command to run after you've written one and give it a few minutes to see if it's working correctly, because if you've got a busy network and you apply a route map and you don't see any packets matching it, you've probably got some configuration incorrect in there. I believe you can use the name there. Yes, if we just wanted to see route map example, there it is. This is really important to run after a policy map, because if you apply that incorrectly, you're going to get some results you didn't expect. You may be stopping traffic that you didn't mean to. But the great thing is, now we've written the route map. I wrote that before we started this lecture. But now I can go back and add to it, because I've decided now, well, any traffic that matches ACLs 31 and 32, I'm going to deny them. So let's take a look at how we'd handle that. I simply configure T, and I'm going to go right back and start configuring the route map example again, and do a permit, and I'm going to go ahead and give it a line of 30. We can do match IP address 31 and match IP address 32. I can put multiple match statements in a route map clause, and they're not going to overwrite each other. And just as you saw earlier, I'm going to set the interface to null 0. So now, let's take a look at show route map example. Now we've got 3 clauses like we expected. And you can see that in the third clause we put in, sequence 30, match clauses has IP address 31 and 32 listed, and a set clause of interface null 0. So now, at this point, traffic that matched these two would be sent to null 0. What about traffic that didn't match any of those at this point? What would happen? They don't have a match in the route map, so what happens is they're sent to the routing engine and routed normally. I think you can see at this point why I really put an emphasis on that, because most of the time in Cisco when we're denying something, that's exactly what happens. But with route maps, we have to get rid of that thinking. That's not what happens. They're actually routed normally. The only thing they're denied is they're denied the change. There's not going to be a path attribute change. One difficulty with policy routing is that policy routing uses process switching. And from your CCNA studies, you're familiar with that term. And what happens is this can lead to connectivity issues with network applications. And I've seen that. I've seen that happen. And to alleviate that issue, PBR now offers fast switching. And if you want some more details than what I've got on the screen, that's fantastic. You know, put it in your favorite search engine. You can also go out to Cisco, practice browsing the Universe CD site that I gave you in an earlier video. And I'll just type that right up here right now too. Cisco.com/UniverseCD. Greatest website in the world. And they didn't pay me to say that. To turn fast switching on, you use an odd-looking command, IP route cache policy, on the interface that you want to enable this. So the command is worth memorizing. It's not really very intuitive. A couple of other details that would be good for you to know is that there's a little bit of a trade-off here. When you're running fast switching, there are two commands that are disabled: set default interface and set IP default next hop. We're going to talk about that latter command some more in just a moment. And there are also some limitations with the set interface command that you saw me use for null 0. And frankly, speaking real world here, they seem to change from one iOS version to another. So just be kind of careful with this. If you ever want to enable fast switching PBR, I would do some searching on it first on Cisco.com or otherwise, and make sure you've got the latest and greatest information. I also want to mention to you, I don't know what other books for the BSCI you may have read. Some of them only mention the set default interface limitation here, but that is not accurate. As of iOS version 12.0, you can't use either one of those two commands when you're running fast switching. So one more command, good one for you to know. To see the contents of the policy route cache, run the command show IP cache policy. And again, not that many of us get to use this a lot, and once you configure it, you walk away from it. But it's good stuff to know. And speaking of that IP default next hop command, I think I'm going to yell at you one more time with capital letters here in a second, and that's going to be it. These commands are not interchangeable, and some people occasionally, some CCNB candidates, think they are or get them mixed up. IP next hop simply means IP next hop. We saw that earlier. If a packet matches this, then make its next hop IP address 10.1.1.1. That command works just the way you think it does. But IP default next hop, if you set this command with a route map, that next hop is going to be used only if an explicit path to the destination network is not present in the routing table. And you're going to have to use an extended ACL to identify this. And the one I've written here, if a packet comes into Ethernet 0, which is where we applied it on the whiteboard, with a source address of 172.1.1.1 and is destined for any host on the 20.1.1.0 network, the next hop IP address will be set to 10.1.1.3 if there is no entry in the routing table for that network. It's kind of it's not a default as much as its last resort. But that's one word you want to watch when you're writing configurations, when you're troubleshooting them, when you're looking at them on your exam. Just make sure that IP default next hop doesn't read to you as IP next hop. You just have to be careful because they're real close to each other. They have totally different meanings. If you just finished watching the BGP videos, I know that's the last thing you want to talk about right now. Yes, it's quite a bit of information. Just a little bit of information here about BGP, I promise. And it's a good scenario to keep in mind. If a specified next hop BGP speaker goes down and there's no alternative path, BGP will actually start using the IP routing table to route packets. So again, this is something you probably will never have to worry about unless you're using BGP at an expert level. in your job, which I hope you do one day if that's what you want to do. But it's a good thing to keep in mind on exam day and for production networks. Again, if a specified next hop BGP speaker goes down and there is no alternative path to get there, BGP will use the IP routing table to start routing packets. Finally, here's an oddity that people notice every once in a while when they're playing around with iOS help, which I think is great, but there's another reason I put this up here, is that there's a common misconception about this. You can instill redundancy into a route map with multiple set interface commands. And I've done that here. And let's call up the routers and write something that looks like that as well. And we'll do a conf t. And we'll call it route map pass BSCI, which is where we're all going to be here pretty shortly. Permit 10. And we're going to do a match IP address 17. And set interface. And you've already seen iOS help here once with Ethernet interfaces. But here I'm setting the interface, and let's use iOS help. And iOS help seems to indicate here that I can put another interface in. And I can. Let's enter serial 0. And do a show route map pass BSCI. And it looks fine. It took it. The router didn't have any problem with me putting multiple interfaces in a single set interface statement. But the meaning of it is very important if you're going to do this. Notice the order in the set clauses remained the same as the way I entered it. I typed in set interface Ethernet 0 serial 0, and the set clauses there near the bottom, it says interface Ethernet 0 serial 0. That is not a coincidence. People occasionally use this command thinking they're performing some kind of load balancing, but they are not. When you specify multiple exit interfaces with a route map, the order is extremely important because the first interface you specify will be the first one used. So if they're both available right now for exit interfaces, all the traffic that matches that line is going to go out Ethernet 0. The only time that second interface comes into play is when the first one is unavailable. So again, this is not load balancing. You don't load balance with set interface commands. The second interface named is only going to be used if the first one is unavailable.